Hi guys, welcome to my YouTube channel. I'm your tutor, Mr. Baraka. This is the last part of our revision, chemistry revision, and therefore I want us to go through a few questions as you prepare for your chemistry paper. So look at the first question. There's a radiation source. There's a particle A, B and C. You can see A is attracted by the negative part of magnetic field, B is not, and C is attracted by the positive part of magnetic field. We said this in radioactivity, that there are three main particles. You have alpha particle, gamma rays and beta particles. We said gamma rays are neutral and therefore they're not affected by magnetic field. And then alpha particles are positively charged, attracted by the negative part of magnetic field. Beta particles are negatively charged, attracted by positive part of magnetic field. So it means then A must be alpha particles, B must be gamma rays, and C must be beta particles. So look at the answer there. You can see A must be alpha particles, B gamma, and then C beta particles. And then the next question says, which particle can be stopped by a thin sheet of paper? Give a reason. We said that alpha particles have the lowest penetration power, therefore they can be stopped by a thin sheet of paper. So the answer is alpha particles, lowest penetration power is the reason. And then gamma rays have the highest penetration power. Therefore it means for a thick lead block, the radiations that are stopped are gamma rays. Reason, they have highest penetration power. Now we go to the next question. You have some cleaning agents here, detergents, RCOO and SO3. You can see, we said this every time you see RCOO and the type of detergent is what? So, soapy detergent. So name the detergent. A is soapy detergent, and then for B it is soapless. Every time you see this one, soapless detergent. You see this one, COO, soapy detergent. And you said that the advantage is that soapless detergent, they do not form scum with hard water. Soapy detergents form scum with hard water. So advantage for this one is does not form scum with hard water. Disadvantage of this one, forms scum with hard water. Advantage of soapy detergent, they are easily biodegradable, therefore they do not cause environmental pollution. This one, soapless detergent, they are non-biodegradable, therefore cause environmental pollution. So each of them has an advantage and a disadvantage, at the same time. We go to 3. Question 3. You state Kcse's principle. This one is based on reaction rates and equilibrium. So you are told this. This is what it states, that when a change in condition is applied to a system in equilibrium, the system moves so as to oppose the change. So every time you have a system that is in equilibrium and you bring a change in conditions, the equilibrium must shift so that you oppose the change. That is Kcse's principle. Now study the reaction below. This reaction is at equilibrium. So you have hydrogen gas, chlorine gas, giving you hydrogen chloride. And then you are told you state and explain the effect of increasing pressure on the system at equilibrium. Now this is what we said. There are many factors that affect equilibrium. One of them is what? Change in pressure. And the pressure affects gases only. It doesn't affect solids. It doesn't affect liquids, only gases. And you can see this one is a gas, and a gas. Now we said this. How does pressure affect equilibrium? You simply compare the volumes of reactants and the products. If the volumes of reactants and products are the same or they are equal, there will be no effect. But if the products have a higher volume than the reactants, there will be a shift in equilibrium. If the reactants have a higher volume than the product, there will also be a shift in equilibrium. So the shift depends on the volumes between reactants and products. So in this case, you can see this one is one volume. So a total of what? 2 volumes this side. And then this side, a total of 2 volumes. So you have 2 volumes. The volumes of the reactants and the products are equal. And because they're equal, it means there will be no effect. So if you are told state and explain the effect on increasing pressure on the equilibrium of this system, then you say the answer is no effect on equilibrium, because the number the number of moles. The number of moles, or you can say volumes. The volumes of reactants and products are equal. If they are equal, there will be no effect. So no effect on equilibrium, because number of moles, so you can say the volumes of reactants and the volume of products are equal. If they are equal, there will be no effect on the position of equilibrium, like that. That is the answer. Then we go to question 4. Question 4 says what? Give two functions of salt bridge. This one is electrochemistry, and we said this, that a salt bridge has two main functions. Number one is supposed to complete. It completes the circuit. Completes circuit by making contact. By making contact between the two electrolytes. So the salt bridge is supposed to be dipped in both electrolytes, left and right half cells. So that's why we say it completes the circuit by making contact between the two electrolytes. And then number 2, the other one is that it maintains what? It's supposed to maintains balance of charges in the electrolytes by providing ions to replace those ions used up or formed. So during the reaction, some ions are used up. If they are used up, then we replace them with what? Ions that are coming from the salt bridge. And then some are also formed. New ones are formed. So you can also get the ions from the salt bridge. So those are the two main functions of a salt bridge. And then part B says what? Given copper half cell and zinc half cell, draw a full electrochemical or a complete electrochemical cell for the two half cells above. And you can see copper has a potential of positive 0.34 volts, zinc has negative 0.76 volts. So we said this, for you to draw an electrochemical cell, you must always compare the two half cells. And we said this, the half cell or the element that is having a negative electrode potential, that element is the one that behaves like a reducing agent. The one with a positive electrode potential behaves like an oxidizing agent. So the reducing agent will lose electrons, and therefore it must be on the left hand side, and the one that is having the positive potential, which is the oxidizing agent, must be on the right hand side, because it is the one that will accept electrons. So electrons in an electrochemical cell, electrons always move from left to right. So in this case, what do we have here? It simply means this, for the first half cell. So this half cell here is supposed to be like this. You're supposed to write it like this. You have zinc solid, and then this one is interface. You go to zinc ions, aqueous, like that, and then there's a salt bridge, and then you go to copper 2 ions, like that. They accept the electrons to give you what? Copper solid, like that. And then the EMF, which is the E naught of the cell, will be given by the 2, which you will see it is positive 1.10 volts, like that. Positive 1.10 volts. So positive because the reaction is visible, the reaction can take place. So it means zinc is more reactive than copper. So zinc gives electrons to copper. So look at this. How do you draw this half cell for zinc? You just draw what? Like a beaker there, and then you take what? Zinc electrode, you dip it inside what? The electrolyte of zinc ions. So it is a metal inside a solution of its own ions, like that. And then I bring the other one For copper, I draw another beaker this side, and then I take a copper rod like that, and then this copper rod is dipped in a solution of copper ions, so I immediately label it. This one is copper solid, this one is copper 2 ions, then this one is zinc solid, this one is zinc 2 ions, and then from here the two electrodes are supposed to be connected by a metallic wire connected to a voltmeter like that. So this one is voltmeter and this one is metallic wire, and then you put an arrow on the metallic wire, not outside, on the metallic wire. This shows what? Electron flow. The arrow shows electrons are moving from left to right. So electrodes are connected by metallic wire connected to a voltmeter. The solutions are connected using a salt bridge. That is why we said here that you complete the circuit by making contact between the two electrolytes. So you bring here your salt bridge like that. This one is your salt bridge, touching both sides. So this one is cotton wool like that. This one becomes what? Salt bridge like that. So you have drawn a complete electrochemical cell showing the two half cells of zinc and copper. So it means here where you have the voltmeter, the reading will be positive 1.10 volts like that. So this one you have drawn. This one here is writing the cell. This one is writing the cell. Here this one is what? Drawing the cell. Drawing the cell like that. Then part C says that calculate the EMF of the cell. So the E naught of the cell, the EMF, the electromotive force of the cell, is given by. It is given by, very simple. You just look at the values over there. That if you have a positive and negative, you always start with the positive. So positive 0.34 minus 0.76 like that. So that you have positive 1.10 V, and the units must be shown, so it is volts, capital V, like that. So we start with what? We start with the cell, the half cell where you have reduction, minus the half cell where you have oxidation. So that's why you have the two. The half cell on the right hand side minus the half cell on the left hand side. So it will give you this. It tells you that the reaction can take place. And then question 5. Question 5 says, state Graham's law of diffusion. This is from 3 work, gas laws, and we said that under the same conditions of pressure and what? Temperature, or temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. So the condition is temperature and pressure must be the same, and then the rate of diffusion of a gas is inversely proportional to the square root of its density. And then now we apply. If the question here, you can see the question is the application of Graham's law. If it takes 30 seconds for 100 cubic centimeters of carbon dioxide to diffuse across a porous plate, how long will it take 150 of nitrogen dioxide to diffuse through the same plate under similar conditions? And then you are given the relative atomic masses. So here I want to use the simplest method for you to get the answer. Just compare the volume. You always compare gases diffusing using what? Similar volumes. So look at here. You have what? 100 cubic centimeters of what? Of carbon dioxide taking what? 30 seconds. So what if it is 150? Because now the volume of nitrogen 4 is 150, but the one of carbon 4 is 100. So what if the volume is 150? Volume of carbon dioxide 150. How much time will be taken? So you just cross multiply, and if you cross multiply, you have 150 times 30 over 100, you will get it is what? 45 seconds. Now once you have that, you come here. The time, the formula now is time and molecular mass. Time of carbon 4 oxide over time of nitrogen 4 oxide equals to the square root of the molecular mass of carbon 4 oxide and molecular mass of nitrogen 4 oxide. So if you look at this one, it becomes easier. Now I'm using 45 over x. We are looking for the time of nitrogen 4 equals to molecular mass of carbon 4 oxide is 44. So from the formula, 12, carbon is 12 plus 16 times 2, 32 plus 12, 44. And then for nitrogen, NO2, you'll get it is 46. So what you will have there? Next thing will be, you get the square root. You take this divided by this, get a value, get the square root. So you will have that over that equals to, the answer for this one is 0.978. After you divide these two and get square root, you get that. So make x the subject of the formula. So x will be 45 over 0.978, and the answer here is what? You'll have 46 seconds. And your answer is there. It's as simple as that. Then we go to question 6. Question 6 says, draw all possible structures of butene. So for you to get the answer, always remember that butene means what? An alkene. Alkenes have general formula CnH2n. So because but means 4, then it means this one must be what? N is 4, C4, therefore H will be what? 4 times 2, you have 8. So you are drawing all the possible structures of this butene. So the first thing, what do? You draw the straight chain. So look at this one. So you have 1, 2, 3, 4. There are 4 carbon atoms. And because it is butene, just put the first carbon, you have a double bond. And then fill hydrogens. Put your hydrogen like that. So I put like this for symmetry. And you see, symmetry will be okay, yeah? So not this way and this way, like this. And then I come there. Every carbon has 4 bonds. So I have 1, 2, 3. The fourth one is there. And then I have 1, 2, 3, and then 4. I have 1, 2, 3, and then 4. Every carbon 4 bonds. The name of this one, the possible name, you start from here. 1, 2, 3, 4. It is 4. So because it is 4, you can see that this one must be what? Must be but. But the position of double bond must be given. So it is but. It will be shown. It is but. Can you see carbon number 1? But 1 in is the name. Then after that, I can do positional isomerism. I change the position from number 1 to number 2. So that I have 1, 2, 3, 4. I bring the double bond there and then I fill hydrogens. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like that. And then 1, 2, 3, and 4. The name changes. 1, 2, carbon number 2. So this one becomes but 2 in. Those are the only isomers that you can get from there. So the possible structures, but 1 in and but 2 in, like that. And then what name is given to the structures shown here? I've already mentioned. These ones are called what? They are called isomers. Same molecular formula, but different structural formula. So these ones are isomers of butene. The last question is hydrocarbon was found to contain 92.3% carbon and the remaining oxygen. Then you're told if its molecular mass is 78, determine if it's this one is supposed to be molecular mass. Its molecular mass is 78, determine the molecular formula. So what do? We said in form 3, you just write what hydrocarbon as carbon and hydrogen. So there are 2 elements that are there, carbon and hydrogen. And then what are you given? You're given percentage composition by mass. The carbon is 92.3, hydrogen will be 100 minus this, so you'll get 7.7. And then what else are you having there? You're having molar mass. The molar mass is coming from here. Carbon is 12, hydrogen is 1. And then if you have the 2, what can you get? You can get moles. So you take 92.3 over 12, 7.7 over 1. So what do you have here? This one gives you 7.7, 7.7. So what do you do next? We said you look for what? Mole ratio. You simplify the number of moles. Mole ratio. So because you are simplifying the ratio, mole ratio will be 7.7 divided by 7.7, 7.7 by 7.7. You have a ratio of 1:1. So because the ratio is 1:1, it means the empirical formula is then C1H1, which is CH. And then after that, what else do you have? Now after getting the empirical formula, it means CH into brackets N gives you what? The molecular mass 78. Carbon is 12. Then you add plus 1 for hydrogen. It gives you what? Into brackets N gives you 78. So you have 13N equals to 78. N equals to 6. So it means molecular formula is actually what? N is 6. So you'll have C6H6. That is the answer to this question. You have calculated the molecular formula for this particular question, and your answer is correct. I want to wish you all the best as you do your exam. May God bless you, and I believe you will make it in chemistry. Thank you.